a weird resolution that it's outputting. But I guess whatever works. If that's what it has to be to work on my thing, we'll live with it. I'll just keep the text big. Anyways, welcome back to Before the Basic Computing. Is my mic yes, it is on. Okay, good. Good. Happy day, Kalukle. Okay. Let me turn off probably should turn off this preview. That's fine. The other thing I need to do is okay, what if I just want to go into one of my live streams? It's going. So annoying. Okay, just do this. But this isn't nothing. There we go. Go to here. Okay, I need to just go to the manage page. Wow. No, it's not made for kids. Okay? This kids not gonna understand this. Okay. This is looking good. Let's go ahead and pop out the chat. And minimize this. Bring this back up. See where we can put chat. Looks like right here is good. Alrighty. Back in business, baby. Oh, what's going on over here? Let's refresh that. Let's see if we can get something. Haha! We have done it. Okay. So I've got all the chats. Anyways, let's get to the board. Okay. Let me bring it up. So back to the workstation here. We can see that we have the program we wrote last time in machine code. For instructions, they're mapped out here. One thing I'm going to do to make this a little bit easier is I'm going to write out their start points for each line. And this should make it easier when I'm writing to know what is going on. Is that right? I think so. 0, 1, 2, 3, 4, 5, 6, 7. Yep. This one starts at 8. 8, 9, 10, 11. And yeah. Oh, this is not 11 though. This is B. Okay, and we jumped to 2B. That makes sense. So that is all correct. And yeah, I'm gonna just start doing this in my program so that it makes jumps easier. It makes everything just easier. Yep, that's right. 1, 2, 3. That's 6 again. That one's 8. And this one is 9. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I am doing it right. Once I'm confident that I'm doing this right, then I won't worry about that anymore. That is wrong. And also in the display system that I'm gonna write using the buttons so that we can get over to keyboard is going to be set up like this, except for it's going to have the 2 bytes of the address. just to make it, because I can jump around and stuff. So just having that, and it'll barely fit here with the address, a colon, the first byte, space, second byte, space, third byte, space, fourth byte, space. And so it can fit up to 4 bytes, which I think is more than any instruction will need, so it should work. This one's 3, this one's 6, this one's 9, this one's B, this one's E, this one's 1, 1, this one should be 1, 3. I think that's right. I'm not sure. But we'll go with this, right? Because I don't have any jumps that need to specifically go anywhere. And we can check it while we're programming, too. Anyways, this is 0, this is 3, and then this is 6. And I should just make it a little bit more easy for me to double check that I haven't skipped anything. Because then I can go, okay, I'm supposed to be here from what's on the board. And I can be like, okay, what's supposed to be there? And that way I can just check it every line, and if I do something wrong, I can go back, fix it right then, and we'll be happy. Okay, so let's see if we can get a program written. Yeah, so I'll just have to unplug this, plug it into positive, and then plug it back over here when I need a program for now. So I do need to add some stuff for that. Because I was originally using the button, and now the button doesn't work. Because it shorts things out. So, I mean, the button still needs to be used for writing, but I don't want the switches to come on when the button comes on. So I could make an active low OR gate, which is an AND gate with some diodes. That should work. Maybe? An active low OR gate. Yeah, I think so. Because if you have an active low OR, it becomes an AND. So we'll make an active low OR gate for this up here, and it'll be good. We just have to figure out where to grab that from. But that should be easy because it was the old spot. So as long as I haven't, in fact, yeah, I still have the wire from the old spot here. So it should be possible. And we'll build that. I do need to find diodes. Oh, I know where I can get diodes. I found my starter kit. So we have diodes. Anyways, let's write the program and just see how it works. And I'll just use the hack for now. So let me see if, okay, I do have the programmer enabled. The CPU is on pause. Let's go ahead and reset it. There we go, it's reset. Okay, and let's go ahead and go over to this mode where we can see the programmer. Because of this change, to load the counter register now, I have to press these 3 buttons, and I have to press them in a these 3 buttons. I have to press them in a fairly specific order. These 2, actually, the order doesn't matter. I just have to have both these down, and then I have to press this button last. So, yeah, I'm going to try to avoid having to load this register with specific values. But if I have to, there is still a way. So anyways, let's go ahead. We need to load this register up proper. Let's just start out with the first one. It's easy enough. So we need to go to 0200. So we go to, let me get my professional programming tool, also known as a pen or pencil. You can also use a screwdriver, though it's metal, so that's why I don't. This is plastic. And we'll enable this, disable the RAM, and magic. And we have a 2 over here now. You see how beautiful that is? Now the problem is I'm not able to read what I'm about to write on here anymore, but there's gonna never be any shorting, which is the beautiful part. Okay, now we disable this. Enable this. Also, you know how you're getting weird values over here? That was because the RAM was getting randomly enabled. So now, it should work every time. Which, I mean, who would think that you could get your programmer to work perfectly every time? I mean, it's almost like it was designed to be that way. But not the first time around. We're already on, like, revision 15 of this entire setup. Anyways. So now we're at 2.0.2.0.02.0.0, which is where we want to be. So we need to put A2 into this. That's already where it needs to be. Let's go ahead and get A in here. Look at that. No shorting when we write to ROM. At least not for more than like a few hundred nanoseconds, because that's the difference in the time to activate everything. And I don't think that's going to cause problems, because it hasn't been causing problems with the CPU, which has to use the exact same circuitry. I'm pretty sure it'll work fine here with the buttons. If it doesn't, okay, we'll have to figure that out. It's fine. Also, because it writes to here, because I was kind of worried about the write timing, but because it writes to here, we should be fine. Because this is probably my most sensitive device as far as getting write timings correct, and it works fine. The RAM, I think, is slightly less sensitive because it was even working when I wasn't doing it correctly, and the ROM as well, it was about the same. But yeah, these are some of my most sensitive devices are the delatches. Yes, delatches. So they aren't synchronous, and you have to make sure that your data is still there when you pull the enable. And it's just working. So if it ends up not working at some point, we'll worry about that when we come to it. Enough talking. Let's get to programming. I can still increment the counter, but you have to have load not enabled. Alright, so the easiest way to switch this back to 0 is to disable everything. Press this, you'll get it back to the highest one, and then just roll it over to 0. And that's the easiest way to do it. And this just went out. So we have not gotten rid of all the gremlins. I was hoping we would have. We have not. What am I going to do about that? It shouldn't be too much of a problem. But this needs to be 0 or 2. But it could become a problem. I was hoping we had gotten rid of that gremlin. Like I said, these are the most sensitive ones. And so, like, if you even breathe on the enable pin, you'll have problems, which is through this one. It's possible that this one's losing power because it's not as well tuned as some of the other ones. Also, it doesn't have a ground loop to help it. Or it does. No, it does. Right here, it's got the ground loop. So it has that. I could chuck a capacitor across these pins, and maybe I will do that. Do I still have more? Yeah. Let's go ahead and do that. Just, you know, throw out the possibilities of whatever. Basically, these chips because they're the selection chips and because there's so many things that have latch enables that need to run properly. I'm gonna go ahead and do it. Okay, that one needs to go in first, I think, and then this one can go in. And there, now we've got a capacitor across the chip. It should help it, and as you can see, it took so much power that we need to rewrite this. So hopefully now it can just provide power, and we'll be good. Which I should. No, I don't have everything enabled for that. Okay, we'll see if that solves the problem. Hopefully it does. It might not. And then we'll just be stuck with that gremlin, and I won't know what to do about it. But I know this chip's been having a lot of problems. Or this one. It's gotta be one of the two. Because when you do this stuff over here with these buttons, all of a sudden, you might have this suddenly erase the read. And I'm like, where'd the read go? And as we've seen, this one, this is the SPI up here. And then, as we've seen, this one suddenly disappears. And it's like, what? Where did it go? So, hopefully, it's not these chips individually, because then I'm going to have to put a capacitor across all of them and see if that fixes it. And if it doesn't, we're really going to be in trouble. But we shall see. Anyways, we want RAM enabled now. Okay, that looks good. This needs to be FF. And, right? Yeah, that seems good. Go ahead and increment. 9A. 9. A. That's supposed to be at 2. Okay. Location 3 has 2, 0. 2, 0. Negative. Like this. And then 0, 0. And then 0, 4. And then we should be at 6. Yep. Should be A9. Oh man, my hand's unsteady, which is not so good. 9. And then 4, 2. 4. Oh, it's all backwards. 4, 2. And then at 8. Okay. It should be 2, 0. So 2, 0. And then 0, 0. And then 5. Okay, and now we should be at B. Is this true? Assuming I did everything correctly. No, we are at A. I did not do everything correctly. Also, is this okay? Okay. So I think I need to go back to... You'll get to see what I mean by 3 buttons to load. I need to go back to 8. Because that'll be 8, 9, 10, and it should be 11. So let's go back to 8. Easy enough. Load enable this. Disable the RAM. I forget. I gotta do this now. And then we can do this. So we go this button, this button, this button. Okay, everything looks good. We turn the RAM back on. We see that we have 2-0, which is correct as we would think. That just loaded it. That's my problem. I keep forgetting to. There's so many switches and buttons the way that I have it set up. It would be so nice if I had room for more logic. Like if I had another 2 boards, we could have this be the fanciest front panel ever. And I'm thinking if I ever make a printed circuit board of this project, that's what I'm going to do. This is going to be decked out to the nines. You're going to be able to just insert stuff, and I might even make it work with non-static processors. Because right now I have a static processor so that it works all the time. If I used a non-static processor, we'd always have to provide a clock, even when it's disabled. But I think I can design it so that you would be able to single clock, single cycle, single jump, insert instruction. There could be so much that happens on here with just more logic or a microcontroller. So, but yeah, this could be like something. This should be 5. This, okay, now we're to B, which is where we should be. 4C, which is this, and these two, that's 2C, 4C. And 0B. So 0B. Let's see, this is B. And then 0-2. 0-2. And I think that does it. We should end at B, A, B, C, B, C, D. So we should be at D. If we are not at D, we are doing bad. That's C, that's D. Perfect. So that should be completely entered correctly. I'm really liking. Let me go over to workstation real quick, where we can see everything. I'm really liking having these line numbers right here. This, the program counter right here at the start of every single line. This is a lifesaver. It allows me to check stuff as I go, and when I did make a mistake, immediately caught it. Immediately could go back and fix it. This is the way we want to do it. So let me go back to the programming screen so that we can see everything. You guys should let me know. Probably in the comments, because I don't know if anyone's watching right now. It doesn't look like it. But maybe. At least no one is commenting. They're chatting. So you guys should let me know if you want like the this screen here somewhere on here, just so you can kind of see what I'm looking at. Maybe I'll do that anyways, because I have the space. If I just paste a reference. I don't think I want to paste reference, because if I put this, let me just see if I want to paste a reference. Does pasting a reference work? Of course, you can hardly see that, but that doesn't cover up anything important, right? Yeah, no, it can be up there. That might be a little busy, and that doesn't mess up the side. Okay, we can paste a reference. I just don't know if we actually want this here. Anyways, I'll put it there. If If it's annoying, let me know. If you liked it there, then let me know that too so that I can continue to do so. All we're covering up with that is the reset button. The reset button's under here. So you won't know when I press reset. Except for you will, because that's the only button under here. Alright. Anyways, we have everything kind of working now. We need to change this. So let's go ahead and go load, disable RAM. And now we can just do this. This is the easy way to reset the counter to 0. Since there's always all ones on the bus, if you have nothing right there, you can just set it to FF. And then FF plus 1 is 0. So that's the easy way to reset. And now we need to write to address 0, which is this one, on the low bus. Do we need to go 3? I think 3, yeah, 3 is a program. Let's go 3. And let's go then. We want to disable low bus, re-enable our RAM. Now we should be ready to program it. So we are here. Let me save this also, because I made its own file, so I can just hit Control-S and it's saved. I really hope. Yeah. I mean, it says it's not muted, and it says it's picking it up, so we should be okay. Should be okay on that. Anyways, this is a really tiny program. I think this is the reset thing. It's a program that might have problems with this jump. Anyways, if it started here, and we jump backwards 6... Oh. 1, 2, 3, 4, 5, 6. We would end up here. We want to end up here. I guess we'll see where this puts us. If it doesn't put us back far enough, we will subtract 1. If it puts us back too far, we will figure that out as well. Anyways, right now we are at 0, 3, 0, 0. Let's write the program. So it's 4, 8. Okay. A9. A9. Let me just double check that. Okay. 8, 0. And now we should be at 3. Okay, we are. 2C. What am I doing over there on the keyboard? Wait. Yes, 3 is 2C. Okay, 7, 0. Is that 7? That's not 7. That's 7. FC, which, as we know now, FC is the correct one for accessing the low bus. FC at 3, 4, 5. We should be at 5. We are not at 5. Now we're at 5. Now we're at 5. Okay. I almost messed up, and that I would have been sad. Okay, now we're on 6, which is supposed to be D0. D is C plus 1. And then 0. FA, F FA. That's supposed to be 7. Okay. Okay, it is. FA, 8. Yep, 6, 8. That's supposed to be on. That's supposed to be off, and that's supposed to be off. 6, 8. And then 6, 0. In location 9. And with all of that, this has stayed the same. That's correct. That's this section of the code done. So now we need to go here. So let's go ahead and go there. So we need to get the counter reset. So turn this off. So I can do this little trick. And I think this capacitor up here might have helped the problem. Solved it? We don't know yet. We haven't done it enough. But I think it's definitely helped the problem. So I think that chip just wasn't having enough power available. It needed more. And so we're giving it more. And so hopefully that's going to keep the glitches away. We've given it its own little personal 10 microfarad battery. And that should do the trick. Technically, it probably only needs like 100 nanofarads. But I can't get my capacitors that are 100 nanofarads to span that kind of gap. So it gets a bigger capacitor. A much bigger one. Oh wait, this is only 1 microfarad. So it's not quite as crazy as what I just said. What does it do? It's more than it needs. You could probably get away with 1 or 10 nanofarads. Which is definitely what you would put on a printed circuit board. But you'd also have more power availability anyways on a printed circuit board because you'd have your ground fill plane and your positive fill plane. And so there would just be like no resistance there for the electrons to get to where they need to go. And it would already have built-in capacitance. So it also reduces noise, and that's just why you can run things a lot faster on a printed circuit board. The distance is also way shorter. Right now we've got miles to go, whereas on a printed circuit board, inches. No more than the entire circuit board, which you can usually fit into 100 by 100 millimeters. Now these things, everything here, I understand, would not fit on 100 by 100. You could maybe, if you squeezed it really, really tight. But if you're going to have all of this, you could probably fit all of this into its own board and still have room for maybe a little bit more. You could fit the CPU, RAM, all of this onto its own board. You wouldn't have any more room, I guarantee that. But you could fit all of this, besides the LEDs, onto its own board. You could fit all of the SPI driver onto its own board, which is currently taking up 2 boards. So, you're talking about really shrinking it down, and then you can stack them on top of each other if you design it to stack. And you'll have just a stack of boards, which is why I have designed this particular bus structure, is so that you could just build modules that stack up. Now you might have a tower, this tall when you're done, but every single printed circuit board only costs you, $2 for 5 or something like that. And as long as you order them all at the same time, actually it's $4. Because it's $2 you have to pay separate shipping because they're special. But it's normally 4. And so $4 per 5 of the same. So you always get 5 copies. And you could just boom. And if you make it so that maybe you need 2 copies on your stack, well then you had the copies. And that only cost you $4. So yeah. A printed circuit board, eventually I want to do it. Shipping's like $10, which is why you might as well order it all at the same time. Because then you're paying $14 for your PCBs. And you only need to pay $4 per PCB. And then you add shipping to all of them. Alright, enough about PCBs, because we're a long way from a PCB. We got to get software that works on here beautifully. Then we can use this to program our PCB version. And then we'll have like a 14. I'm hoping to get chips that run really fast. And we can get 14 megahertz out of this CPU, which is its max. And that'll be good. If we can get 14 megahertz out of that CPU, oh, baby, we'll be zooming. And then we'll upgrade to an ARM. Maybe. I'm just dreaming right now. It's not necessarily going to happen, but we could eventually upgrade it from the 6502, 65816, which right now we're using like a 6502 because we're in emulation mode. It's all 6502. Eventually we'll use its advanced features, and yeah, and eventually we'll upgrade the hardware. Oh, I'm getting distracted. We gotta write this code. I'm over here dreaming, and you don't want to hear about the dreams. You want to see things happen. I'd like to see some things happen too. Alright, where was I? Okay, I must have been loading this thing. Because that's what everything is set up to do. So, are we good to write to it? This is wrong. This is right. Okay. So now that we've done that, we disable this. We enable this. And now we're at 4 or 0400. Oh, the other thing, if we ever get this on a printed circuit board, is I can get the SPI up to 20 megahertz, which will greatly increase that speed. And the cool thing is, because most devices run at 20 megahertz SPI, at least. Some of them even do 40. If you can ever run 40, you're like in the gold. Which on a PCB we probably can, but not everything can use 40, so you can't rely on that. Whereas if you rely on doing everything at 20, then it takes like 8 clock cycles of the CPU and you can read it, so there's no point in ever doing interrupts. Just do something for those 8 clock cycles that you know you're going to have to do, and it'll be done. It'll be done. Because if you're running that at 20, you're running that at 14, you're basically running it at the same rate. You know every instruction is going to take you at least 2 clock cycles. That means that you're running at about half the speed. And so that'll take 8 clock cycles to output every bit. And your CPU will will just have to waste those 8 clock cycles doing something else. And if you're using that time to read the next byte that you want to send, to read it in, and then you adjust your pointer as well during that time, that's at least 4 clock cycles right there, probably 6. And then you jump back in your loop. There's another at least 2, probably up to 9. Your SPI is already done by the time you get back there. So there's things you can do to have a very efficient SPI where it's almost like reading off of RAM. Now there's a trick with the 816 you can do. I don't know why I'm explaining all this right now. I gotta explain it. I'm excited about this, okay? There's a trick where it actually has an instruction to move a block of memory to another block. This is extremely fast. And because every clock cycle it moves the next byte. Or maybe it's every 2. It takes 2 clock cycles to move memory, which is better than like the 5 or 6 clock cycles you usually have to use. So copying memory is pretty fast. And that's why I've actually set this up so that I can copy like 16 bytes at a time, so that we can do it a little bit faster to the screen. But we'll see if that ever comes to fruition, because that means you have to set up 16 bytes, and maybe not. Where was I? We're at 40. We're at 0400. We are about to write a program. We are at 0. Our RAM's enabled. Our counter is disabled. Load disabled. We're good to go. Let's get to writing. And let me just write this program. 48. Next. 1 is supposed to be A9. Next. 01. Next, we should be at 3. Yep. 8. D. Okay. 70. Next, this should be probably FC. Where should I be? 6. That is 6. So 20. 0, 0. Where I need to be? I think so. 7. Yep. 0, 3. Now I should be at 9. And yes, that is true. A 9. Just this one. We have A9, 3, 8. Ah. Oh, that's not quite up. 3, 8. We should be at B. We are. 8D is what we want here. That can stay up. 8. D. We're in the right location for this, right? We're at B. It looks like it. There was just that was a pattern that I had used before. I mean, sometimes it happens because it's just random data that's in there. 7, 0. Yeah. Okay. I just have to remember where I am. So we're at C. So yeah, 7, 0. 7, 0. F, C. Okay, now we should be at, what is that? E? Okay. 2, 0. So let's 2, 0. 0, 0. 0, 3. And now we should be at 1. What is that? 1, 1. All right, good, good, good. Everything's working. So this should be a 9. 0B. B is this one. 0P. And then we should be at 1, 3. 1, 3. Oh, baby. So this will be 8D. 70. Wow, that's a lot of stuff. 70, and then this will be the FC. Okay, and then this should be 1, 6. If not. So I just messed that up. We can put in what's supposed to be here. 1, 6 is supposed to be 6, 0. Okay. Now let's go back to 1, 3. So to go back, we gotta do this. Make sure that that's where that's supposed to be. Okay. We get to go back to 1, 3. Load enable this. Everything else is disabled. This. We can now re-enable this. Re-disable this. Okay, and what I should have here at 1, 3 is 8D. We do. Okay, so this one is correct. Next one should be 7, 0. And it is. This one should be FC. Okay, that's fine as well. Go to the next one. This one should be 6, 8. Am I reading this wrong? That's all I can think of. Because this is 1. Well, now wait a minute. This is 1, 6. Did I count something off wrong here? That's the only thing I can think of. Oh, I did. Because if this is 1, 3, 4, 5, 6. So it was right. That was wrong. But you see how easy it is? We can just go, we can find what the problem is. I mean, I love the way we're doing this right now. I'm actually feeling good programming this because I'm like, you know what? This is easy enough. I can do it again. And I don't mind doing it again, but probably only once more. So we need to get a copy program that can copy to the ROM here soon. So that way I can write in RAM and we can block write in ROM. And we will write. Well, we don't need to write that program in ROM. We just need to be able to run the program from ROM. So we can write it in RAM. Test it in RAM? Yeah, we could. If we write it properly, we can test it in RAM. And it'll be like the universal copy. Because it'll work for RAM and ROM. Because ROM, ooh, don't put that finger up. Because ROM has a very special, its writes are very special, in that they can take up to a millisecond, which is extremely slow on some clock speeds. And so we need to make sure that it has written before we try to write again. Now, we also need to be running our clock at a fairly decent clip, so that way we can do block writes, which allows us to write like 64 bytes all at once, and then we can wait until they have written. And that's pretty important. And I don't know which one you should check. If you should check the last one, you should check the last one. Because the last one will give you the inverse of... if you read from the ROM while it's writing, it gives you the inverse version, which means the inverted version, you know, the not version. It inverts all the bits of whatever you last wrote. And so you should check the last one to see when you finally read the thing that you expected to be there. Because it should be the last thing written. Anyways, it's all a little complex. And so we need to write a very special function to be able to transfer and write to EEPROM. And that way the device can write to itself. And then we can prototype in RAM and then copy to EEPROM, which will be good. Because then I can save my work. And when you can save your work, you don't have to keep typing it in. You just copy it back later. And it'll be a very rudimentary file system because I'll just write down, oh, I saved whatever to EEPROM address, and then we can load the work back, and it'll be great. And then we can write to SPI and get SPI working, because SPI would be lovely, because then I have 128K of EEPROM to write to, which is a lot. We could even boot from SPI EEPROM, though I'm not sure we will. I also have extra SPI EEPROM chips. So, oh wait, we have 256K of SPI EEPROM. So I'm probably going to use that mostly for like lookup tables later. You know, it could have the boot code in it, but so could, I mean, this has to have boot code in it. But the boot code could just say, okay, boot from SPI EEPROM. Because then we don't have to fit our code into 32K, though we probably can fit our boot code into 32K. We can fit it into 64 because we can have the boot code load everything into the first 32K of RAM. We can then have that load everything into the last 32K of RAM. And suddenly we have a lot of RAM space. And then we can load everything from the SPI EEPROM into 64K of RAM. And because SPI EEPROM is such a simple thing, we don't have to have a file system or anything to do that. And we get a lot of RAM. Then the EEPROM, if we want to, we can boot from a file, because the EEPROM can have a file system thing. It can have SD card driver, and it doesn't have to have a file system. We can just have it have a very specific sector that it looks for to boot, and it can boot from that sector, and we'll call it good. And we'll make that sector not usable by an x86 machine, so that it doesn't try to boot 6502 assembly. We'll have a different sector for that, probably the FAT file system. We'll just use its standard boot sector. If it has a way to boot the operating system, we'll just use that. And if it doesn't, we'll just have the FAT file sector say, you cannot boot from this device. And that'll work. And we'll all be happy. But we'll have a very specific sector. In the master boot record, we can have 4 sectors. But what we can do is we can make a special sector that only our machines know about, that can boot 6502, Z80, whatever. And it can just know, okay, it's booting from here, it's booting from here, it's booting from here. Whatever we need to boot from, we can do that. Anyways, dreams again. Once again, distracted by dreams. Okay, so 1.6, is that where we are? We're at 1.6. It's supposed to have 6.8. So let's go ahead. Let's get 6 and then 8. And then the next one, 1.7, is supposed to have 6.0. All right, that's that program written. Boy, it took us forever to get there because I went off on a tangent again. I love dreaming about what the thing can do, but getting there is always going to take months to years of work, and it's like, oh, we're never going to get there. But I plan to. I want to get there. So now, that's it for that program. We can go to the next one. So we need to get the counter back to 0. Let's do that. Counter back to 0. Now we need to put low bus enable on, and we need to get to 5, because this is where we're writing our final function, actually, which is the print character function. So let's do it. To do this function, I need to do this and this. Yes. That's what we need to do. And now that I have this function, now that I'm in the proper address, we're at 50500, which is here. We should be good to write. So let's go ahead and go to 0, which is what goes here. Oh, there's nothing to keep that information. 2, 0. 2, 0. Okay, yep. We have that turned off, right? I think so. Yes. 2, 0, 0, 0. It should be 2, 3. And then at 3, we should have 8D. And then 7, 1. Oh, I have not adjusted this to be proper. 7. That's not 7. 7, 1 at 4. Okay. 7, 1 FC at not 1. Okay, and then we should be at 6. We will be. And we need to do 6, 0, which is return. This was by far the simplest function. And that should be done. So now, assuming all this code is actually correct, we should get the screen initialized and print the character. What character were we printing again? M? I think so. Well, I guess we can look. I put in a B. That's right, B. Because we're doing the first letter of the channel. So let's give it a try. First run, well, third run, but first run today after programming it all in. Here we go. How long did that take us to program? Take me to program that in? Only 37 minutes, even with all the tangents. So if I had just sat down and done it, you know, we probably would have done it, because I spent like 20 to 15 minutes talking. Could have done it in like 15 minutes. So it's really not that bad. It's really not. All right. Let's go ahead. Let's run it. So to run, I need to think about this. I need to put this over here. Over here. Nope, that's fine, because that's just the output. So as long as it didn't mess anything up, it's fine. Okay, so now it's permanently disabled. So these buttons are permanently disabled. Okay. So now everything else is good to go. we should be able to let the CPU take control. We have an issue here, and that is that the CPU has not taken control. Oh, no, it probably has. Here we go. It's working. Let's go. I wish I can make these a little bit more dim. By adjusting these resistors. Maybe I will for capture because it is very hard for you guys to see. Though we won't be using these LEDs for much longer. But yeah, they are actually can get brighter. Okay, these are already dimmed down. They can get so bright that it hurts my eyes, let alone a camera. It would just wash it out all the way. But this is the lowest amount of exposure I can get on this camera, and this is my more expensive camera. So in order to get any lower, I actually have to literally dim the LEDs by changing the drive resistors. And maybe I will, so that you guys can see it a bit better. You can kind of see that they're different colors. You've got the blue, the green, and they each represent different bits, and you can almost see it, but you can't see it. So, yeah, maybe I'll do that next time. But for just the Hello World program, we'll do it this way, because you can see the switches that I was putting in, and so you know what's supposed to be there. Okay, let's go ahead and get through the reset. Let me actually go ahead and turn off the pause, because while I'm clocking it myself, we don't need to pause. All right, so this is now somewhere. Okay, it's executing the jump instruction. We're now in RAM in the program we just wrote. So we're up here. So what should happen is, we should load that. We should go do that, which will take a clock cycle. And then we should go to here. Okay, so now it should do something on the stack. A couple things on the stack. And now we should be at our new spot, which should be 400. And that is where we are. So this first instruction should be 48. It is. And that is just a push instruction, so it's going to do something on the stack. It hasn't done anything on the stack yet. There it goes. That should be the stack location. Yep. Okay, now we're back. A901. Or A9 is the first thing. A9 is a load instruction. So there we go. Yep, it's working as intended. 8D is a write instruction. So this is the very first time we should write to the LCD. This light should turn on. Low bus should come on. The whole 9 yards should happen. So there's the first part of our address. Second part of our address, or high part. Okay, load that in. And this time, it should be a write. Oh my word, it's writing to the LCD. Now, nothing's going to happen here because I just told it to clear the screen. So, let's go ahead. And, okay, now it's going to wait for the LCD to be done. We do need to check this code. So, now it should jump to... So this is the jump instruction, or the call subroutine. It should go to 200003. Okay, now it's got to do some stack operations. There's the two stack operations. Now we are in this code. We are here. So the first thing it's going to do is push A to the stack. So this should generate a stack operation. There's the stack operation. Next up, it should load. No, it should, yes, it is loading something into A. So there we go. And then it's going to read the LCD. So we should see that. So the address, the enable for the LCD, maybe it'll come on when I hit the clock cycle. I think that's what it is, because it is clock gated. So yes. So we're reading. We should not jump, and we should go to 8. So this is D0. That is a 6-0. Or a 6-6-8. Did we already check the jump instruction? Where are we? We're at 6. Why am I already doing 6-8? I guess I missed the jump instruction. Whoops. We are in 3-0, right? Yeah, so we're at 0-3-0-6. We should have been D0. It is instead 6-8. So what's the next instruction going to be? I think it has to do something on the stack. No, it doesn't. We're now at 0-8, which is... Maybe I was reading it wrong. 6-8. Now it's 6-0. Okay, maybe it did the whole thing correctly and I was being stupid. Okay, yep, now we're returning. Just as I think we should be. We did return, right? We are now in 3-0-3. Okay. I don't know where we are. What? We're in 0-3, 9. And now we're at 3. Now we're going into no man's land because we are at 3A, which we definitely should not be. Okay. So either we didn't get the correct value off the stack, or something else happened. Let's just check to make sure. 6-0 is the command we want. It's right here. Return from subroutine. 6-0. Okay. Let's go ahead, reset, and get back here. Because something weird happened. 6-8 is also pull A, right? And 4-8 is push A. That's what we gotta check. 6-8 is pull A. Oh, you know what? If it did pull A twice, like I think it did, then it would not have the correct return value. And could go anywhere. Okay. Let's reset and see exactly what it loads at that point. Because if it gets here, and this is not D0, but rather 6-8, it's going to pull A. This will mess up our stack, and it'll just die. So I have no idea what it will then read from stack, but it won't be correct. So let's go ahead and let's reset. Okay, and let's get back to just location 3. So we're going through, we're doing our stuff. We're now calling something else, which is now calling something else? No, we're good. Oh, we are not good. We are in no man's land. What happened? Why am I in no man's land? Oh, that was not no man's land. That was the LCD. So we just did something with the LCD. Okay. Now, pushing to stack. And it's definitely writing stuff. So it should be working. Now we are at the start of 3. So we should be at 4, 8. Yep. 4, 8 is correct. A9. That looks right. Which then should go into... Oh, right. This is pushing A onto stack. So what is the value of A then? A is 1. Is that? Yeah, A should be 1. Okay, so that's now on the stack in theory. Now we are at instruction 1 still? What's it doing? Oh, right, 4, 8. I just pushed on the stack. So now we're at instruction 1. A9, which loads A. So this will load A, which is 80. Perfect. And the next one should be instruction 3, which should be 2C. That is what it is. 70. FC. This should be accessing... Oh, this should be accessing the LCD. Right here. And it should be writing... it should be reading. So whatever's coming back from the LCD, which is apparently 0. Okay, now it should be doing a D0. Okay, it is actually doing D0. As we can see here, we have D, which are these ones, because that's C and then that's D, and then that's those 4 are 0. So it is doing what I asked. If we move forward, it should be FA. And we know that we got all zeros back, so it should just move on, because it was 0. Oh yeah, it's got to read now. Or no. Oh, right, FA is where it would go to, but it's not going to go anywhere because it'll just skip it. So I'll never know whether that works or not until I speed it up, and then we definitely won't know. So I guess I'll have to go somewhere and test a branch instruction to remember how that works. Anyways, 6, 8 is something. That should be where we are. Okay, and this should pull A back off the stack. So this is a good chance to see if the stack's working. I don't know that I saw it do anything with the stack. Now it's doing stuff with the stack, but I think that's because this is return stuff. So it's pulling 1. Okay, so that was the A value. And then, where are we now? Okay, so it just pulled A, which I think is correct. And now it should run 6-0, which is what we have here. Okay, let's see what this pulls off the stack. I would hope that that's to set up what we're pulling off the stack. Not when it is. Okay, so now it's pulling off the stack. What looks to be correct. So it's pulling off a 5? A 4. A 4. A 0-4. And then it should pull off a 0. What is this? Oh, what? Oh, okay. No, that might be right. And then it's pulling off 0-8. That looks like another 0-4. So I don't know what that's about. But I know that moved. So maybe it was a 0-8 on the first one, which would be weird because I didn't put anything in 0-8. Oh. Oh, okay. Maybe it's 0-4, 0-8. That would make sense. And would it make sense? Because did I call it from 0-4, 0-8? No, but if it goes to 9 next, then it's correct. Which would be here. So if it comes back here and goes ahead and adds 1, then that would be correct, because this would be 6, 7, 8. So it comes back here as 1. I don't know exactly how the return function works, so I guess we're going to find out. Why did it pull 3? Or seem to pull 3. It might not have pulled 3. Let me go ahead and look up for the return from subroutine. Okay, here. Make sure that there's not like a return from subroutine long that we're using or something. We aren't. So it should only pull 2. If it's pulling 3, it's being really, really weird. Okay, so now, at this point, we should be back at... And maybe it worked the first time, and I was just reading it wrong. Totally possible. This should be 4, which it is. And this should be 9, which it is. Okay. Okay. So, I think it was working correctly the first time. Either that, or something weird glitch happened, and, yeah. Anyways, so on this instruction, we should be here at A9, which we are, and it should do 3-8 next. Yes. Okay, so now we have loaded 3-8 into the thing. Now we should be doing 8D. Alright, 7-0. FC. And now it should write that to the LCD. Oh, it worked! The LCD! But apparently it just took it a little while. So, anyways, screen initialized properly. So, we're good. Okay, then we got to go back. We're going to call the other function. We're doing our stuff. That's its read. Should have read 0. We're hoping. Okay, now it's going to jump back. In theory. And yes, it did. Okay, so this next instruction should turn on the display and get us a blinking cursor. This is where the moment of truth comes in. Here it is. I don't see a blinking cursor. I'll check that instruction and see if I did it correctly. I will also check the other instruction and see if I did that one correctly. At this point, though, I'm not counting on anything being good. But anyways, we should be able to run the rest of this program out. And it should just do nothing forever at some point here. Okay, there it probably wrote, like, something. Definitely doing something wrong. Let's reset and just see what we can get to happen here. What are we doing in ROM? That's weird. Okay. Let me go ahead and put this back on single step. And let's go ahead and step it. So, yeah. Okay, I'd love to power this off and just this. Because I want to see if the initialization steps kind of work. Now, I will say this wasn't doing exactly what I expected it. If we reset and run, this should initialize in theory, right? There it cleared the screen, there it read, there it initialized, there it should have turned it on, and there it should have written the thing. And now it's doing something weird. Because for whatever reason, the jump forever instruction is not working. So it is for C to jump, right? Jump absolute is for C. And then it should be 0B, 02. But it's not. The only other thing that could cause problems is if it goes here and doesn't return. But everything I see here would say that it should return. So, anyways, the blinking cursor thing has me worried, which means I didn't initialize it right, or I didn't do something else. So let's check those numbers. So first things first, initialize LCD, which is 400. So I go ahead and do clear screen. I could do this after the initialization, might help. Function set, I put down as 3.8. Which might be wrong because I do remember this one was a bit weird. So it needs 1, 2, 1. Then it needs DL, which is 1. N, which is the number of lines, which I think is 1. F, which should be 0. And then whatever you want to put. And so this turns into there is no 3 in this number. Let's see. So this is the proper, or is it 3, 8? Oh, maybe it is. Because that's the most significant. So you go down, that's a 3, and that's an 8. So if I'm looking at this, then, well, let's check the display then. For display on off, we want it to be 0, 0. So it's just the last 4 bits, right, that control this. We want the display on. We want cursor off. And then we want blinking cursor on. Okay, I already see the problem. Because I just wrote it down wrong. So that should be a D. We have B. So what did I end up doing here instead? Is the question. What I ended up doing was a B, which is this. Am I going the right way? This is least significant, so that's C, D. Yeah, I went backwards. And what I instead did is I left the display off with that instruction. So let's go fix that. Oh boy. Let's go ahead and just disable everything. Make sure everything's disabled before I start doing this. Okay. Put this on the right enabled pin, which is this one. Honestly, we can go over here and grab it, I think. Yeah. So let's get out there and fix this. So it's 411 is where we need to go. Actually, 412 if we want to be exact. So first we got to go to 4 on the low bus. Let's reset this, right? For some reason. Okay. Load enable. Right. Let's get this reset. Actually, I need to load it with something. But for now, I need to reset it. Right. And then we can load it with something. Okay. Because I need to set this one. And this should do it if I enable low bus. Okay. Now, disable low bus. Now we need to write this one. So this one is, we want to go to 1, 2. So go to 1, 2. And do the trick. There's still a problem up here with that doing some things to the... Oh, no, because that was off. This hasn't been reset. So that was fine. That should have happened. Also, it helps to put the CPU on pause. Okay. Because I just don't want it doing stuff. It'll just be doing random stuff. Not that it'll do anything because the bus is disabled, but it'll start doing things. What do we have here? We first need to enable the RAM again. Okay. That is not at all what I expected to see. Oh, that's because I'm at 8. I did all that work, and now we have to undo it all. Because I need to be at 4, not 8. Good job, me. Four. Get it right. Okay. Now we gotta load 1, 2 in. Yeah, this is when things take a long time, when you gotta actually jump somewhere. Okay. And then we got everything off, right? Looks like it. Then we can re-enable this. This should have our B in it, which was wrong. We want D. That is what we want in it. There we go. Now it should enable the screen. And we might even write a character to it, if we're lucky. Okay. So, let's do it. Let's write a character. Now I was going to do the Hello World program as it should be done, but pointers in 6502 are tricky. So, what I will probably do instead is just take this function and copy this bit. Copy this bit? Copy this bit and not do this bit up here where I load it in. Wherever I do that, I think it's up here. I won't do this, or I will leave it and just call it nothing. And then I'll do that a lot down here. And then we'll be good. Okay. So I made the fix technically. Let's disable everything. Then I can move this over here and also disable it. Now I can turn this back on, make sure everything's right. Okay, it is. Now we can disable the bus and allow the processor to take over again. We'll go ahead and reset it. There's reset. Now we should be able to let it run. And we will see what happens. Let me actually quickly do this because otherwise it'll just remain as is. And while we do need to check that that works, I think it would be way more interesting. Oh, it remained in power. Come on, lose your power. To see the whole thing. Okay, so let's go ahead, reset, allow it to free run. There we go, it reset the screen. Should have a read coming up soon, I think. What's it doing? We're off in no man's land for some reason. Let me just reset it, rerun. Let's see what happens. we end up in no man's land again, which we are. Something broke. Now, I'm not sure what. So what we got to do is we got to like either single step or something like that. Okay, this is the instruction to jump. This is the instruction to do something. Let's see here. We are at 2, 0. So should be A2. Okay. Now it should be 9A. That is not 9A. Or is it? No. Right, we are at 2, 2. Okay. Well, there's your problem. How did that get adjusted? I don't know. I'm trying to think of problems that might have happened. Just don't know. Oh, it's messing up my program again. So things are happening, and I'm not happy about it. I'm not happy. Okay, single clock. Let's go in and fix it. I'm not happy, bub. Not happy. Ask me why. That's because no, that's on the same pin. Oh, it should be read write. I know it has to take read write. I'm not sure. Turn on bus enable. Make sure the processor is paused. Okay. ROM's disabled. Yep. Okay. Okay. We'll get there. Just make sure this is correct. Yeah, it is. And then let's head into the user program space. So that's 2. Did I at some point mess myself up? That would really be bad. We aren't ready. We are not ready for all of that. Okay, this needs to be 0. Okay, now we're good there. We need to write 2 into here. And there we go. Oh my word. Now we can just start here. I'm okay with that. So let's disable this, or enable that. So this starts out at A2, which is good. That's what it should be. It's then FF. That's fine. It's now supposed to be 9A. It's not even close. While I'm here, I'm going to check the rest. It's then supposed to be 2, 0. That's fine. It's supposed to be 0. It's supposed to be 4. It's supposed to be A9. It's supposed to be 4.2. What could have happened is while the CPU was doing whatever junk it was doing, it could have accidentally overwritten that 1 byte. Where am I? 7? Supposed to be 4.2? Okay. 8. No, 2.0. Okay, we're good. 0, 5, 4C, 0B. Yeah, that was right. And 0.2. Okay, so it all looks right still. So I think that's what happened. Is it there was something overwrote that value somehow, very specifically, and he killed it. Okay, let's see if everything else runs properly at this point. So we should be able to, if we disable this, we should be able to go ahead and hand control back over to the CPU. Okay, and we could single step, or we could just let it run. A single step would be safer if I single cycle. Let's single cycle. Let's just see what happens. Because I might run into another problem, which could cause more problems. So, turn RAM on. Chip is enabled. We're going to single cycle, so everything is okay. And here we go. So let's go ahead and get that reset in. Get that jump in. Now we're good to go. We have now bootloaded into the RAM. So we are here. So first is A2. And it should go FF. Okay. Then it's 9A. Which is it? Already wrong again? Why? Did I put it in wrong? What happened? This is currently 6A. Now, one thing is that it's the same as the switches. But I didn't do anything with the switches. What? Is that what I put in there? Because that's just wrong. It must have been because it was where my switches were left. Oh my. Can I? No, it would short the thing, wouldn't it? Well, yeah, it would. No. No, because if a write happens from either, it allows the write through. So, in theory, I can hotfix this. I'm not sure if I can get the thing to read it though. So that is 9A. Why didn't that? Oh, maybe I pressed that button. Did that work? I don't know. That's the problem. But what we can do is we can reset and see if the hotfix worked. Let me disable the RAM first because now I don't want it to write suddenly. Okay, we can re-enable. Okay. Let's just reset now. Alright, and here goes. Okay, now it's going to do a jump instruction in theory, right? Did it fix it? It did not. I was hoping, but it didn't fix it. It's supposed to be if a write comes through from either one, then it writes. But apparently not. So I'm gonna have to go back and do the whole thing. Okay, let's do the rigmarole. Do the rigmarole. Hopefully, though, most things are set up the way they need to be. We'll find out when we get there. This needs to go back to here. Okay. And forward? Backwards? I can't remember. So I'm in bus enable, and I need to get to... Okay, that one's correct. It's just this that's probably not. It needs to go to 0, 2. Easy enough to get to. We can also enable the RAM, because that's A2, FF, and then this is supposed to be 9A, which is what we have loaded up. Now it should be correct. So now if we do the whole thing again, and we turn that off, turn this so that it never works, turn this on so that we're using the CPU, and turn this off, reset, clock it a couple times, go to here. Okay. We are now ready to rumble. We need to also enable this. Okay, the jump instruction. Did that happen correctly? Yeah, it did. Okay. That time we had 9A. Now it's 2-0. Okay. It's just now reading it. 2-0, 0-0, 0-4. And that's going to do something. Now that's a branch instruction, so it's going to branch. Okay, they just wrote to the stack. We have now branched to here. Okay. Which is supposed to be 4-8. Right. No. What is it doing? No. That's supposed to be a 9. I think what happened, something occurred, and it could have been my fault. No? Because this is at 1. It's a different spot. But anyways, this is supposed to be A9. So I think I just got to go through, check the code, see what happened, see what's deleted for whatever reason, because apparently this one is a 1 now. What's it doing? Oh, maybe this was part of the 4-8 instruction. Hold on. We will come back. That's still 1. Alright, see there it took the opcode. It's 1, and then it went again, and it's still 1. Which is correct, but also very incorrect. So, let's disable this before I ruin something. Okay, this is what I get for just free running the code when I don't know if it's going to loop properly at the end. Because it didn't. Yep, and it just, I think it broke stuff. I don't think it was me. I think the code just randomly wrote to random places and things happen because it's all weird. It doesn't act as if it was some sweeping right thing. It just seems like it's random positions that it's written to. And it could be hardware. It could have been me accidentally leaving ROM on at some point. I don't think it was. So we're going to go ahead and we're going to go in here. And we're going to probably reset this. Yeah, reset it. And then we're going to go to where we need to go, which is... was I looking in the wrong spot? I might have been. It was still wrong. That's not going to go anywhere. Now it has somewhere to go. I thought it had somewhere to go. Ah. Did I? I did. Let's see. What is going on here? Okay. There we go. Now it's all correct. Okay, now this goes off. This turns on. All I want to know is if things are right. How did you do this to me? How did you write this? What? This is completely wrong. Except for it's probably completely right for that one. Oh my word. Turn this off. Turn this on. Okay. That's still wrong. How did you manage to do it twice? That is correct. Turn this on. This off. Okay. Now we've got what should be here, which is 4 and then 8. Okay. That's right. So then we need to check the next one. This better be not. Okay, it's not. It should be a 9, which it is not. Okay, and this is supposed to be a 9. Boom. Next one is supposed to be 1. Next one is supposed to be 8D. Next one is supposed to be 70, and then FC. And then we're supposed to have 20, 0003. And it's supposed to be A9. Okay. 38. Yep. 8D. 70 FC. 2003. A9. 38. That's not 38. Am I looking at the right one is the next question. Probably not, because that's probably supposed to be 0D. Because we are at 1. 1, 2. Yes. So 0D. Alright, so that is right. And then, 8D. 70. FC 6860. Okay. And then whatever. So that one is now fixed. Let me go check on 30. Everything's disabled at the moment. Good. Do this. Okay. So 30. Enable this. We do the same. What did that just do for me? It did nothing. I do have it enabled though. And oh. There we go. That was proper. Okay, so now we're at 3 over here. We disable this, enable the RAM. We start checking. 4.8 is what that's supposed to be. That's supposed to be 4.8. I mean, it's not, is it? No, it's definitely not. Okay, so that one should now be correct. That should be A9 80 2C 70 FC D0. Yep. FA. Whoa. Oh no, that's right. 6860. Okay. See, in every single block, it erased exactly 1. And I don't know what did it. And it's always a different one, too. No, stack can't go up there in emulation mode. I was going to say, oh, maybe it was the stack, but stack's not allowed to go up there in emulation mode. At least it shouldn't be. It's supposed to loop inside the 0-1 bank. Okay, so I've checked this one, I've checked this one, I've checked this one. The last one to check is 5. Which really, let's check it. It doesn't particularly need to be checked, but it could help us. Don't do that one. Well, see if we can do that one. Because it doesn't read anything. I mean, once it does, it'll be a problem. But right now, it doesn't. Okay, so 5. There we go. So now we just have to go and check all of 5. So let's go check it. It's supposed to start out with 20. That is correct. And it goes 00. And it goes 03. And it goes 8D. And it goes 7-1. And it goes FC. And it goes 6-0. Okay, so that program was completely fine. It was smaller, so maybe it messed up a byte later on. This should now run properly, but I'm not just going to let it free run because we saw what happened last time. So let's see if we can get everything to work. So first of all, I'm going to do something. I'm going to reset this because maybe that's what overwrote everything. Maybe we had a bad write in there somewhere. And it like just completely mauled everything. Oh. You know what? The power surge. I didn't think about that, and that could ruin RAM. Most things might be okay. It might have erased a few again. Aha. So we can't unplug and plug this back in. That doesn't work. Well, let's go single step. We'll see if it broke it again. If it did, I'll go do this again, and then we'll just know, don't unplug this. Bad idea. Which, I mean, obviously hot plugging it was a bad idea in the first place. I just wasn't thinking that that would be the problem. Because if our RAM lost too much voltage, it will have erased some of it. That's just the way it works. Okay, so while I have everything disabled here, let's disable the right pin. Wait a minute. Okay, no, because that's supposed to be 2 0, so that is correct. So we'll just have to look at it as I single step through. But yeah, I'm beginning to think that might have just really screwed everything up. Oh, I didn't have the CPU on pause, but that's okay. It's not able to do anything. Okay, so we are where we need to be as far as most things go, I think. Everything is enabled that needs to be. Everything is disabled that needs to be. We are ready. So let's begin single stepping the clock. So here's our reset. As per usual. Okay. First instruction. A2. That's fine. FF. We're good. 9A. Beautiful. 2 0. Okay. 0 0. Oh no, we're still on 2 0. 2 0. 0 0. 0 4. Okay. Still not done with whatever that's doing. Oh, it's jumping now. Of course. Okay, so now we have jumped. We have jumped to 4 0. 0. Okay. We're here now. We're here now. So 4 8. Yep. What does 4 8 do? It pushes. So it's gonna do something wild here. Yeah. A9 into 1. Looks like it kept the program this time, luckily. 8D 70 FC. So this should be right to the LCD. Good, good. 2 0. Oh. Okay, this is a jump. We're there. Now we're up here, which is 4 8. A9. It probably does a push. Alright, A9, 0 1, 8D. That is not AD. It did erase a little bit. Gosh darn it. Is that important? That is an important instruction. Okay. So do not unplug this. I'm going to rewrite the program. Luckily, the first 2 sections, and this is important to remember, Oh wait, where are we right now? We're in 3. What am I saying? 2C. Ah, we're okay. Woo! Don't get confused on where you are, because that is bad. That is really bad. All right, 2C. Yep, we're still okay. 2C. 70 should be the next one. FC. This should be a read. There it is. Then this should do nothing but go on to the next bit. 6860. Okay, yep, now it's gotta do some stack manipulations. Doing stack manipulations right now? Yes, it is. Okay. Oh, right, it was popping off A. Now it's gonna pop and return. Now we are back here at 8 9. We're here. This is all correct. Okay, and then it's gonna load that one. Then it's gonna load 8D is what this should be. Okay. 70. Yeah. FC. Yep. Okay. We should do another right here to the LCD. There, we did it. Now we should be here. This should jump us back to the other function, which we know works, so we can kind of speed through it. First stack manipulation, now we need 2 more. There they are. I think it takes 3 actually on return, but it's not actually loading anything off the stack. It's just, it needs 3 clock cycles. Now we should be back here. That is where we are. This should turn the display on if we did it right finally. Okay, now we're at 8D70 FC. And this should be display turn on. It works! Blinking cursor! Oh man, okay. So now what's gonna happen? Well, now we're gonna return, actually. So we should go back. So are we in the 6-8 instruction right now? We are. So that's gonna do that. And now we should go to 6-0 instruction. Oh, what's it doing? Okay, it's popping off the stack. Pop off the stack. Okay, we should now be back at 200 somewhere. We're at 206, which would be here. So this should be a load instruction, A9. It is. It's going to load M42. Okay. Yep. Then do 20. And it's going to do a call instruction here. So yep, so there we go. 05. Pushing the stuff to the stack. And now we're there. Now we're here. So now this one's going to do a call. And that call is going to go So here and there, yeah. Okay, we know that this instruction should work. There it did the read. Now it should be coming back soon. There's its first write. There's its other writes. And so when we come back, we should be back. Okay, yeah, we're at 5.3. So we're here. This should do the write to the LCD. We have a B. The code worked. Oh my word. Okay, and now we should be returning. Where are we? Hmm. 5, 7. Okay, so this is a nonsensical thing because we're branching. We're back. We're back at 2. What is that? B. So we're back here, which is where we should be. Now it's supposed to jump to B. But is that B? That is B. So it should jump here. That's what it should do. We should be in a forever loop. Okay, so single stepping the code works just fine. We are now looping forever. Let's go ahead and clock this and see if everything works out the way it's supposed to. Clear the screen, turn it on, or enable it, turn it on, and then, where's my B? Putting it on the clock doesn't work. And I'm not sure why. Let's clock it even slower. Hopefully it didn't ruin the code. Or maybe I really am just not letting it run long enough. Well, no, because it goes into ROM. So we're currently in 3. Now we're in 5. We were in 4. Now we're back in 3. We were in here somewhere. Okay, so it's still in the initialization process. What are we doing wrong now? Okay, so here's where it messes up. I have no idea where this comes from and what it's doing. So let's go ahead and let's put it back into manual clock. Let's see what's going on, if we can. I need to see what part messed up. So, we're here. We're having a good time. We reset. Now I'm in somewhere. Okay, I'm at the starter code, which is supposed to be A2. Okay. Yep, that all works. Then we need to go to 9A. Is 320? It is. Mom, that didn't seem to work. Hold on. Okay, what we have here is A2. All right. FF. 9A is what this is supposed to be. Okay, it is. Then we have 20. Okay. And 00 and 04. Right. So that all works. That's where we should be going. Okay, we're down here now. 48 is what we should start out with. Which I assume we did. Okay, yeah, it looks like it. Then A9, 01, yep. 8D is what I now need, yep. 8D, 70, FC. We have to mess, everything's working as intended right now. Then we come to here, and we get 3, 4, 3? 4, 0? Alright, now it's messed up. But if that branch started happening, I could see how we could get off somewhere weird because the code stops working at that point. So I'm probably doing the branch wrong. I'm doing it slowly enough right now that it doesn't matter and we'll never hit it. But during that faster clock, we could have hit it. Anyways, we're at 6, 4, 6. So it should be 20. Okay. 200003. Okay. That is correct. And then 09. Although now we're going to head off to 3. Which is up here. So it's going to be 00. is going to be 4, 8. It is not. It is just 8. Now there's your problem. Okay. So this got overwritten, which is a problem. Oh boy. However, it makes me feel like the RAM lost power. Which it might have. I don't think, though, that I have a big enough capacitor to span my RAM, which is maybe a problem. Now, this might erase everything, but we know it works. And so if this does, so I'm probably going to be done for today here in a bit. But I just want to make it so that I'm not suddenly losing junk. Now, can this span the RAM? It cannot. Is there anything else that goes to the positive side? Okay. There is a way to do this. To get it just across. Okay. We can go to ground over here. And then there is a positive terminal right here that I can maybe go into. So let's get in there. Oh, that's the wrong side to put on that side. Is it close enough? Not quite. And try going into this side first. And then going in here. Every time it's like just fighting it. There. In theory, that has spanned the RAM. And then it just has a little path to get up here, which is fine. That's not going to hurt anything. Now the RAM has permanent power. So only if it writes something can other things hurt it. Now I need to go here to check that out. Technically, I should try with all chips to span it. That's going to be so annoying. But basically, let's go fix 3. It's one of the more important ones, so... And the fact that nothing changed here kind of makes me hope that adding that capacitor didn't hurt anything immediately. And I don't think it did. So, let's try it. So first things first, disable the RAM. Disable the CPU. Pause it. 2. And then... What do we need? What do we got here? We got a 0 and an F. This is all as it should be. Somehow. Don't know how. Yeah, we do have the bus enabled. We're currently at 5. We want to be at 3. There we go. So, now that we have 3, we want to go to here. Yep. Disable this. Enable the RAM. Let's take a look at it. We are currently here. This should be 4, 8. Four, 8. Okay, then it should be a 9. A 9. Should be 80. Yep. 2C. Or not 2C. 70. FC. D0. FA. 68. 60. Okay, the rest of that was correct. It was just that one byte. I have half a mind to just let it clock itself at this point. But at this slower 1 second clock. Let's try it. That's what I say. Let's just try it. Let's see what happens. Go ahead and turn the RAM back on. Let's get this reset. Get it on the 1 second clock. Everything's enabled that needs to be. Okay, I think we're good to go. Oh, I have it paused. Okay, so every 2 times this LED comes on, that was an instruction, right? So let's just watch for that. That was 1 time. Has it gone off to Neverland again? That was 2 times. So no, it hasn't. Hopefully. So that should have been 1 time through. That should have been just the clear screen. Okay. There's 1 time. That should have been turned to display on. It would seem like I'm off in Neverland, I think. I am definitely off in Neverland. Alright. What broke to put me in Neverland? Because it doesn't matter. If I'm running it off that clock and not the button, it does not work. So what is causing that is the question. How come my clocks are either not clear and I'm clocking too many times? We can check that by going to the absolutely slowest clock. And we're going to watch this like a hawk. It has already gone to garbly. Okay. Okay. So I think some arrangement messed up everything. That's weird. Okay, that's why. So now we have to go see what got messed up. So I think the capacitor did kind of clear some of our stuff. So let's go through all the different programs just to check them, write what needs to be written, and then try it. So A2FF9A 0. So we need to go to 2 first. Let's go ahead. Are we already in 2? Well, the processor's in 2. Who knows why? Yeah, pause the processor. Go ahead and give it some resets. Okay. And we turn off the RAM for now. We need to go to 2. We'll come back and check 3 again as well. But I need to be going to 2. Okay, let's check it out. So this is supposed to be A2. Perfect. That's supposed to be FF. Yep. 9A. That's not 9A. In fact, that's A9. That's like way off. You ready to see how off that one was? Way off. Okay, next one up is 80. That doesn't look like 80. Wait a minute. What just happened here? I'm at 3 somehow. 3 is supposed to be... Oh, no. Maybe that was fine, because I was reading the wrong one. Let's reset. I might have been okay. Well, it might have been half okay. It was still wrong. So this is supposed to be... Not this. What just happened? Oh. Okay, so this is supposed to be A2. Yep. This is supposed to be FF. Okay, this is supposed to be 9A. What do you know? It is. So it was wrong. This is supposed to be... If I have this right... Okay, this is supposed to be 20. So... Yes. That's right. Then 0, then 4. Okay. Then it's supposed to be A9. Yep. Then 4, 2. Yep. Okay. Then 2, 0, 0, 5. 4C, 0B. We're at what? B? No, we're at A. Okay. 4C. Yep. 0B and 2. Okay. This first function has now been checked and is correct. Disable that. Okay. The next one to go to is 3. So we load this. Zero it out. Enable this. We write 3. This one should be correct because I haven't... Because I fixed it after the capacitor. Yes. No, I didn't. I actually didn't look at it after the capacitor addition. So we need to go check. Let's get everything right. Okay. So I can already see it's wrong. Oh boy. So right, so we're here at 0, 3, right? Which is 4, 8. Let me just make sure I'm in the right spot. 0, 3, 0, 0. It's supposed to be 4, 8. Then A9. Boy, I am sure I'm in the right spot, right? Okay, I was not for that one. Which is okay. As long as we recognize it, that's fine. First one is 4, 8. Still the same, right? 4, 8. Yep, okay. Second one is A9. Alright, that was already correct. We just didn't know it. Then, this is a 2. Yeah? This is supposed to be 8, 0. Okay, okay. I was looking at the wrong spot again. 4, 8, A9, 8, 0. Okay, we're good. Then it's supposed to be 2C. Okay, 7, 0. Alright, FC, D0. Alright, FA, 6, 8, 6, 0. Okay, the rest of that's good. So now we turn off this again. I do this again. I do this again. Do this. You do that. And then what you do is you have all that. You need to go to 4. And this is technically the only other important function, but I still will check 5. Okay, so this one starts out with 4, 8, just like everybody else. Yep. A9. Okay. 1, 8D. 7, 0. FC. 2, 0. 0, 3. It's supposed to be A9. Okay, which one's this one? I just came from 9. This is supposed to be 3, 8. Okay, that looks right then. 8D. 7, 0. FC. 2, 0. 0. 3. A9. 0D. And this would be like 8D. 7, 0. FC. 6, 8. 6, 0. End program. Okay, or end function. Okay. So that one was 100% correct for whatever reason. Go here, 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 here. Then we can enable this. We can go to 5. All right, let's check the program. 20. All right, that's what that's supposed to be. 0003 8D 71 FC 60. Okay, that one was correct as well. So now, turn off the RAM temporarily. Shift this over. See, it was a good thing I turned off that RAM. I just would have written something. Okay, re-enable the bus. Okay, I think we're good to go on everything now. We can redo this to the thing. We can allow it to clock as slow as molasses. And we can watch it as it runs through the instruction. It looks to be currently running correctly. Yep, okay, it's putting stuff on stack. There's it taking something off of stack. And there's one write to the LCD. Or I guess I should say one LCD access. Should be doing another LCD access here soon. Okay, there's the second one. So that's one round of LCD. There's one LCD axis. Okay, it should be coming up soon with the read. That should be the read. So up next should be... Okay, so that turned the screen on finally. And so we should be heading back here soon to something. Are we heading? We're heading into 3. I mean, I guess that might be good. I don't remember going back into 3 though. Yeah, something wrong happened here. So where are we jumping out to? I mean, I guess it still has a chance to work. Because that was a read, in theory. That should have been the right there. Now where am I? I'm back in 3. Okay. Why? Why when I clock it with this clock, it do not work? But when I clock it with this clock, it work. Makes absolutely no sense. Anyways, hopefully I saved it this time before it wrote anything weird. So if I just clock through with this one, it probably won't work. At least I'm back into the original function when I clock it this way. And I was in 5 there for a split second. Now where have I gone? I've gone into no man's land. How did I get here? I'm not sure. But that's where I am. Doing who knows what to the RAM now. Okay, so let's think about how many times it should go into 3. It should go there twice. Yes? Yes. If it goes there more than that without jumping back first, then we got a problem. So here's once. Hmm. I feel like it just reset. I can't do it. I'm trying to do a Chewbacca there. That did not work. Okay, let's read it. And just see what in the world is going on. That's supposed to be 4.8. It is not 4.8. Because it's not supposed to be. Okay, good. It's supposed to be A2. That is what that is. 9A. Okay. 2-0. And then 0. And then 4. And it goes off and does some weird stuff. Then we're into a 9. Wait, no. We're now in 3. And 4 even. So this is supposed to be 4.8. Okay. That's fine. 4.8. Then A9. A9, yeah. Well, A9. Okay. Then... Zero, 1. I'm in the wrong spot again. Okay, so we're here. Okay. So that's correct. Then it's supposed to send it. Well, it sent it. Now we go to the spot. 2, 0. What is this? Shouldn't that be 0, 0? Here, I'm currently at 4, 8. Nope, that should be 3. Okay. Okay, and then at 3, it's supposed to be 4, 8, which it is not. Why? I know I checked over this and I fixed everything. So why is it not 4, 8 now? I mean, I can go back and fix it, but I need to know why we're rewriting everything. When I'm clocking it with the other clock. Why are things getting written where they're not supposed to? But it works fine when I clock it by hand and it's doing the exact same stuff. It's doing the exact same stuff. Hold on. What am I doing? Go look at it again. I'll re-enable this. We're currently at 3, 0. It should be 4, 8. Okay. Just wanted to make sure that I wasn't going crazy. This one I might actually be able to rewrite on the fly. Because I can just freeze the processor. This one needs to be what? 3, 8? 4, 8. We're at 3, 0. So 4, 8. 4, 8. The right enables are supposed to be ordered together. That's what keeps confusing me. If I put it over here, I can't use the value there anymore. That's all I need. I just need for it to be enabled, but not do the other thing. What happens if I just force it? I can't force it because the CPU's there. Pulling things down already. and I can't pull them up. That makes sense. Yeah. Yep. So I have to go in and do the whole rigmarole to get this to work. So what is causing write problems? Basically, it has to be these chips over here not getting enough power or something. Where do my two write enables come in? They should come in somewhere. Okay, it's this one and this one. They come into here and they come out here. They go down here and get inverted. Yes. Let's see how they come out, right? Because right now we should have a read. If I try to write, it doesn't seem to matter. What do you think you're doing coming out of there, huh? Get back in there. Well, yeah, okay. So that's not the output. That might be part of why. It still does not matter. Well, then where does this one come from, right? Because it should be coming from the right pin. Output, I would have thought. Oh, of course, I added a safety measure, so I couldn't do it without bus enable being enabled. Okay. However, that doesn't matter so much anymore. Okay, well, I'll leave the safety feature in for now. Crap. What I need to do then is let's take care of everything. Yeah. Okay. So that's not gonna work. Unless if I forcibly tie it to a 1. Not recommended, but could be done. Oh, hi, we're gonna lose. Yep. It's a bit inspired by Ben Eater's machine, but it's a lot more complicated. It's got a lot more stuff going on. The mess of the wires is all the logic that has to happen for the front panel to work and for everything else to work. So, because it's basically got the programmer on the board instead of having the programmer separate. But I keep running into problems because it's more complicated. So, yeah. This needs to be 4.8, and it keeps getting messed up. I've single clocked through it, the code works. When I clock over here. When I run it off the system clock, it no worky. And so I need to figure out why. And I'm beginning to think it's a problem of these, though, like, you can't see that one. I've got these capacitors running across some of the more important chips. So I'm beginning to think maybe I need to do that elsewhere to get things working better. Just because I think it might be a power availability problem. And so... it would be best if I could do it to every single chip. I don't think I can. If it ends up that I have to, I guess I'll figure it out. And see, what you can't see is all of this. See, it's got a lot more machinery. No, it's only a 5 volt 1 amp power supply. But I've checked it, and the voltage is fine. So it's just the fact that I'm on a breadboard that power isn't getting around to where it needs to be. Anyways, bring this back down to the program review. But yeah, I've checked the voltage rails, and it seems to be fine most of the time. So... even if all kinds of things are getting enabled, it should still be okay. It's definitely not okay at 500 milliamps. At half an amp, does not work. But at everything else, it should be okay. I could grab a 2 amp 5 volt, see if that works. But I don't think it'll change much. Because when I add the capacitors, it starts working okay. Which would mean that it's basically having trouble getting the power to where it needs to go. So... and it's just in individual parts of the board or individual chips, and it's like, no. So I'm not sure. I don't really want to unplug it though, because then I'd have to reprogram it using the switches. So we're gonna try to make it work this way. And it might be that these clocks aren't getting enough power, in which case I can smooth that out with a couple capacitors. Let me go ahead and do that. I still need to fix the program, but this will help. Because it's just on this clock that it stops working. But that could be a lot of things, because there's a lot of things on this clock that I use that I wouldn't use otherwise. Breaking into my second box of capacitors here. Yeah, I know. And if I'm getting jitter from the clock dividers losing power, then it would be a problem. Because actually, it's funny, but my manual button is the one that works better right now. So I know it's nice and sharp. So just add these for mini batteries for these individual things, and it should help it. In fact, let me just do this for at least one chip on every single part of the board, and this will give it a continuity across, which should help in theory. Just do it. Don't let your memes be dreams. Okay, do I have one down here? I do not have one down here. Let's check one down here. One of these chips. This will hopefully just clear up all the problems. Because the other problem I'm having is my RAM suddenly gets rewritten for no good reason. The only thing I can think of is logic messing up. Which it will if it runs low on power. Okay, I have one there. I need one up here. This one's kind of component busy. I don't like that too much. But perhaps we can make it work. Yeah, that one's not going to work so well. I don't have a good way to do this one, do I? Okay, I have a decent way. A decent way has been found. No, that's not too decent, actually. There. Darn it. That'll work. Power to ground. Power to ground. Because technically, this is what you would do on a printed circuit board, and it would be great. Yeah, I have an oscilloscope, but I don't have any probes for that thing, so... I also have a voltmeter, but it doesn't work either. So I need to get some new tools again. Okay, this one, positive to ground. Just keep that stuff away. Alright, now I have a capacitor going across. Not using that stuff, it should be fine. Even if that stuff messes up, I'm not using it, so we're good. Down here, I've got one. I should put one up here. Where did they go? They're over here. Yeah, the really hard way. The hard way being that I can't check actual voltages. I have an LED attached to this wire, and I'm just poking it in places to see if it's high or low. So, it's just guesswork. And when I have gotten that to work, though, that's when I've checked the voltages, and they were okay. It's because the probes on my voltmeter aren't working either, so it's a lot of fun. Let's see, so I need plus to ground up here. Is there an easy way? Not really. Yeah, that is very true. It's, though maybe if I regulated it a bit, well, I say regulated a bit more, I'm regulating it with the capacitors, so it should be fairly regulated. I could have built it into the board. I haven't yet. And I don't think I will for the breadboard. because everything runs at 5 volts. No need to. That's not the right pin. That is. Alright, I technically have a capacitor crossing most of the boards. This one is only my buttons, so it's... Is it only my buttons? Is that true? That might not be true. You had your board in your project for last exam. You got zapped. Oh, and you killed the chip. That's the worst. I mean, getting zapped is really bad too. But killing your chip is the second worst thing. So you had the 2 worst things happen to you. Alright. I've got capacitors everywhere. Where don't I have a capacitor? Down there. Okay, let's put a couple more capacitors on the board. One for this section. And then one for this section. Come on. Come on. Go. 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 Yes. Oh, that should make connection. Okay. Now, to go back, fix this because that code's wrong. Because that's here. It's supposed to be 4.8. It is not 4.8. Oh, this is the worst part. Switching over to manual mode. Because I don't have the board set up right anymore because I had the logic wrong when I designed it. Third worst thing without being able to go to the shop. Yeah. Oh yeah, that's really bad. Really bad when the electricity goes through the heart. I hope you're okay after all that. I mean, I assume you are, but yikes. Right, we were gonna write. Okay. So disable RAM, ROM. Turn this stuff off. We need to go to 3. So enable this because it doesn't write anything out. Oh, okay. I see. So it wasn't this time. It was a different time. Or something like that, Yeah, that's really bad. I've gotten zapped quite a few times, but it's always luckily been through like my hand. So and nothing's come of it except for my hand hurt for a little bit. But yeah, I know you don't want to accidentally you don't want to work. That's why if you're like doing electrical in a house, you don't use 2 hands. You just use your one and try to do it. Because if you accidentally touch both wires with opposite hands, and yeah, or it goes through one arm. The hot goes through the arm and down to the ground. Either way is not good. Not good at all. Yeah, it was in the time where there were a lot of analog things around. Yeah. Analog. Kind of need a lot of power, and I think you usually use differential signals on that, right? So you've got like a lot of voltage going on. Anyways, 3 here. So we need to zero this out. Where's this 3 coming from? That's never a good sign. Never a good sign when you disable everything. Right, that's disabled. So these 2 should be disabled. Ow. It's impossible. Okay, not entirely impossible. I can figure out a way for it to happen. Because I don't have pull-up resistors. Oh, my word. That'll mess things up. Man, I can't wait till when I figure out all the problems with this board. Because then it'll run like a dream. Right, I have pull-up resistors on the other side of that, but if that gets enabled, then it dies. So it needs pull-up resistors on this side as well. Did that remove the thing? No, it didn't. How is it still enabled? Pull-ups on the thing now, right? So on. That's a 0. Well, where does that come from? And is that, oh, that's the output enabled. We don't care about that. Of course, that's a 0. It's this one that which one do I care about? Care about this one. Sorry that you can't see this. It's just a hardware glitch. Have I released it now? I still have not released it. How is that possible? Because for some reason this chip enable is still 0. Even though oh, of course it is. Oh my word. I'm using a 65-816. So the big brother, the big 16-bit brother of the 6502. If I just hit this reset button, it should fix itself. Or not. Why isn't it fixing itself? Did I do something to make it always enabled? Somehow, I guess. Well, may need to do something about that then. Well, what I can do is just unplug the one that is enabled. So this one. For now, I've got to relook at this high bus stuff later. I'm not even using it right now, so there's no point in having it there. Still got the pull-up resistor in there, so that'll stay forever. So make sure it just never comes on, and I'll look at it again later when I actually start using it. So now I can do what I need to do. We can go there, yep. Do that. And then do this. Okay. So now we are ready. That is the main problem. I need to figure that out, how to do that. I honestly need to gate it on the high bus. So, anyways, here's the problem bit. Could be 4.8. Oh boy, that just probably killed the entire thing. Oh man. Okay, let's go check the whole program again. And then do it. I really wish I had more logic to make the programmer better. It's too easy to accidentally leave something on and then you do something catastrophic. So we start out 2. We have that off right now, yeah? Okay. And I have that off. Turn it back on. Okay, turn that off, turn this on. It's been destroyed. So we're here. Which we need A2. Yeah. A2. Next up is FF. Okay, luckily that didn't get wiped. 9A. That's still good. 2 0 0 0 4. A9. 4 2 2 0 0 5. 4 C 0 B and then 0 2. Okay, most of that didn't get wiped, just the first one. Which is possibly true for everything, because that's the one I was on. I was on the first byte, and then I, like, wiped through all the different addresses all at once accidentally. So we need to disable this. Otherwise, we're going to run into the same problem. Rewrite this. Redo this. Rewrite. Enable that. Okay. That did nothing, and it should have done nothing. Now it did something. Okay. So this is 3, which is where we want to be. This is very wrong. That should be 4, 8. How did it already get messed up again? Oh, maybe it is 4, 8. It's not. It's already gone back to that point. This is the one I just rewrote, isn't it? I must have a wire cross somewhere, I swear. Because this is literally what I just fixed. Maybe it didn't fix it. That's right, because it switched off of it. So it probably, this is probably still broken, is what it is. Not that it broke the same way. It just never got fixed. 4, 8. Make sure we aren't enabling that. Okay, that's correct now. So now A9, 80, 2C, 70, FC. Well, that was quick, but that was right. D0, FA, 68, 60. Okay, that one's correct now. I didn't happen to like leave address pins floating, did I? That would do it. No, I didn't. They all have something going to them. Okay. We need to go to 4 now. Which 4? To get to 4, we do this, that. No. All right, bank 4. We're in bank 4. 0. Re-enable RAM. What do we got? 4, 8. Correct. A9, 1, 8D, 70, 2, 0, 3, A9, 3, 8, 8D, 70, FC, 2, 0, 3, A9, 0D, 8D, 70, FC, 6, 8, 60. Luckily, that one didn't get messed up. Well, the last one to check would be 50. I guess I will since I'm here. 500. All right, and here we start with 20. That's correct. 0, 3, 8D, 71, FC, 60. All right. So This is now, if you wanted to see, I'll show you real quick. I have it all written out in assembly up here. And then this is when I assembled it by hand. And like I say, I've checked this code. It works. It does work. But not the way that it wasn't working with the automatic clock, which is weird. But it was working with my clock. So I'm going to go through it with my clock again now that I've, in theory, got it fixed. We'll disable the RAM for a second. Put this back to permanently disabled. We will allow... We will allow the processor to take over again. Then we can re-enable this. Now the processor has taken over. That's weird. It shouldn't be accessing RAM, it should be accessing ROM. Huh. Well, I guess we'll see what it does in a second. Although, you know what? That has to do with the same problem. Yeah. Now it's working right. That had to do with the same problem as the other thing I was having. So that's not good. In fact, the things weren't resetting properly and staying reset when I did. It could be bad. Could be bad. But for now, we'll leave it alone. As long as it doesn't start having problems. We'll figure that out real fast. Okay. So let's go ahead. Let's let the processor go free run. And we'll just clock it manually here. And I would check the code, but at the moment, I don't care if it's working right or not. I just don't want it to overwrite anything. It should be working right for the most part, I think. Oh, but no, it's already not working. Darn it. Ah. Go through reset. Come on. Okay, we're through reset. This is a jump instruction. What was that? I think I'm going too far. Don't tell me that somehow in all this the ROM got messed up. Oh, now we're reading from RAM again. How does that happen? How? The reset button literally doesn't allow that to happen. Okay, there we go. This is reset. Oh, what? Yeah, it's like magic, alright. And I'm not sure what kind of magic this thing is working on me right now. Okay, no, that's right. When it's down here, this should be active. But Mm. That is wrong. And I don't know why it's doing that. Can you even see that? Not quite. Try to move this a bit. This means that it's accessing RAM. This is not a RAM address. This is a ROM address. So the fact that it's accessing it that way means that something got messed up. The one chip that runs everything is this one. I believe it's this wire. Is that true? That must not be the wire. There's one of these wires that decides whether it can access ROM and RAM or only RAM. One thing I can think of is that one of these capacitors. It's permanent, proper. Those ones up there are good. This one here, always positive, always ground. This one here is always positive, always ground. Oh, I'm getting in the way. Oh, you know what? Is this floating? It's not floating. It's coming down here. I wasn't watching for that. It works at the start. Like right now, it's working. At this point, it's still working. That time it worked. Oh boy. Alright, goodbye. Hopefully my board is fixed by then. It's really getting on my nerves at this point. There's so many little things that are just going wrong. But yeah. Bye-bye. See you later. Have a good day. Oh boy. How long have I been live for? 2 hours and 20 minutes. Managed to get the code to work once, and then it hasn't. Ooh. We're suddenly somewhere random again. Where are we? I don't know. It should jump there. What is it doing? It says jump to 0? Wait, nope, it's wrong again. What is this instruction that it's running? It must not be the jump instruction anymore. That one is... Let's see, I expect jump. I'll make this the easy one. I expect jump instruction. It is for C. That's for C, alright. But then it goes off to Neverland. And now we're in RAM and we're supposed to be still in ROM. Why does it get disabled? Oh, now we're really bad. Okay. So something's happening up here. And it's not happy fun times. I can tell you that much. So one of these things should be on reset. And it should come down this way. And if it doesn't, then I need to figure out why not. Okay, it's not that one. Where else can we output from? Here? 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 That's an output of some sort. Where is it going though? Nowhere? So therefore, it must be this one. Okay, and it does come over here. So if we reset, this should go high. And there it went low for some reason. Oh, I guess I need to go either look at that chip or just permanently tie this pin high that it goes to. Or something I could try, though it probably won't help, is doing it with this. But the thing about that is it doesn't matter. for some reason that flip-flop is triggering. I need to know why. Let me go look up the data sheet. The data sheet for A7412. I don't know if it's HCT, ACT, what it is, but they all have the same pinout. Clock pulse. Clock pulse. So 4 down on the right and the top left. Okay, clock pulse is correct. I could tie this always to value of some sort. Like, you know, if I always tied it high, it should never be able to go down. If it does, we know there's something seriously wrong. There's still something weird going on with the processor. It always feels the need to do weird stuff. Because when we're going through the reset, okay, here's what I expect. The reset vector. Yeah, that's what that is. 4C, which should be a jump instruction. And am I in the emulation mode anymore? That is the question. I am still in emulation mode. We're still good there. But it doesn't move. Or it doesn't do anything. Here. Which is weird. Then it goes weird to somewhere weird down below. Okay. What I'm going to do is something I really wish I didn't have to do. And after this, we'll just have the stream be done. Because I've checked the code works. I'm going to power down the board and power it back on. And see if that fixes the problem. Nope. Whatever problem it's having. Is not caused by that. And then it ends up somewhere weird. Because of course it does. Why? Ugh. The only other thing that can output is this stuff. As far as I know. Oh. Why did that just flicker the thing? Oh. It's these getting touched together. That's causing problems. Something does seem to be shorting out, which is odd. It worked properly this time. And I had it in single step mode. I mean, who knows what this code's gonna do, because it's not correct anymore. But okay, take it out of single step mode. What happens? Here we go. We're resetting. There we go. Right here. I don't know. What made it work again? Makes absolutely no sense. And there's nothing that outputs on these lines other than the processor and me. I don't know. I doubt I was fast enough on the unplugged plug that the RAM still has memory. I mean, it could. The capacitors, it does have its own capacitor that would last a little bit. But I did wait 5 seconds, so. What's it supposed to be? It's supposed to be A2. It is not A2. So yeah, I'd have to go back in and rewrite the whole program. So I might spend a little bit of time by myself at some point trying to figure this out, why it's doing what it's doing. But for today, that's definitely gonna have to be it. I'm getting tired again and annoyed, and when little problems like that crop up, it's like, where did that come from? I don't know. Let me go ahead and plug this other thing back in and see if it started working or if it's being weird. Let's see, yep, that's the one I permanently plugged into positive. Let me go ahead and plug it back into where it's supposed to be, which is here. Reset the board again and let's see if it works. What was that? Did that work? That did work. Okay. I don't know what happened. Maybe one of those capacitors had some stray charge on it or something, so it was doing something weird. But now at this point, it all works again, so I don't know. All of my capacitors are plugged in correctly. They're plugged across ground and +5, so nothing weird's gonna happen there. Ground and +5. Ground and +5. Over here, ground and +5. Ground +5. Ground +5. No. I don't know. anyways, I'm gonna plug this code again in, again by hand, by myself. You saw that I did it here, by hand. You don't need to see it again. So I'll get it plugged in, make sure the normal clock's working, make sure that everything's good, and yeah, I'll see y'all next time. Let me just check something real fast because I'm curious. Yeah, it's still warm. So I don't understand why things suddenly had problems, but they did. And now they don't. Who knows? So anyways, until next time, I will see you all later. Bye.